Welcome back. Before we jump into the math, let's take a break to relax ourselves. And instead of doing a brief meditation, we're going to do some stretching. It's early morning for me, so it'll be great to stretch. And you may not have thought about it, but the SAT test is really long. It's 3 hours. So that's 3 hours of intense test taking. And actually, the math is the second half. So you're going to be sitting for an hour and a half doing a reading test before you even start the math test, which itself is an hour and a half. So it's always good to just stretch and get the circulation going and relax your muscles so that when you sit down and do the math part, you're feeling refreshed. So that's what we're going to practice today. So I know this might look silly, but I don't care. So stand up and just stand really tall. In fact, I'll tell you what I'm doing. I am clasping my hands together behind my back and I'm pulling my arms down and opening up my shoulders. Feel that. Open up. Okay, we'll start with the head. Just take nice forward and back motions real slowly, like you're saying yes. And feel the range of the neck movement there. Look to the right and left slowly, like you're saying no. Tip your head forward. We're going to make circles in the clockwise direction. So you're going to roll your head to the right and to the back and to the left and forward. And just feel the full range of your neck opening up. Oh, I just heard a crack. Now you're going to go to the left. So down, left, up, right, and down. And see how full a range of motion you can make. Now shoulders. You're going to go forward, up, back, down. And again, try to make these circles as big as you can. Down, back, up, and forward. We're going to twist our spine, so keep your hips stable toward the front. We're going to twist our chest to the left. See how far you can go. You can even pull your arms back behind you if you want. And then we're going to go back center and to the right. See how far you can twist your torso nice and long. Roll your hips, little circles to the right and to the left. Again, can you make big circles and feel that range of motion? And then you're gonna lift your right leg up, do circles with your ankle, each direction, seeing how big a circle you can make. And then just shake your arms out, shake your legs out, and then sit down again. And you can do any of those motions over and over again to work out the kinks in your body. And hopefully you have a little more circulation going, you feel a little more fresh. You can even do these while you're seated during the test if you want. Like, other people might think I'm crazy, but I don't care. But it's really important to get the flow of the blood going, because the more relaxed you're going to feel in your body with good blood circulation, the better focused you'll be able to be. So I hope you enjoyed that, and then we'll launch into the math problem right now. This is a problem from the College Board. It says, if x is greater than 3, which of the following is equivalent to that fraction? And you have 4 choices. So have a look at this, give it a try, and if you don't know what to do, don't worry about it. Just try your best, and if you need to, just go ahead and make a guess. And we'll have a look at this after a minute or so. question is from the section of the SAT math test that does not allow calculators. It's 25 minutes long for 20 questions. So that's really rapid. So when I saw this problem, I thought, man, to simplify that algebraic expression is going to take me a while. There must be an easier way. So I thought I could set x equal to some value, find out what that would make the expression in the question equal to, and then find the matching value in the answer choices when I do that same substitution. So honestly, this is what I did when I saw this question. I said, let's pick a value for x that's easy to work with, and I picked my favorite value, which is 0. Now, we're going rogue because they told us that x is greater than 3, and I've picked a value that violates that. But I said, I don't care. Let's see what happens. So just watch and bear with me. So we're substituting 0 in for x in the original expression, so the numerator doesn't change, and I'll end up then with 1 over 2, because 0 plus 2 is 2, plus 1 over 3, because 0 plus 3 is 3. Now when I have two fractions added together in the denominator, I have to find the common denominator, which is 6. So 1/2 is 3/6, and 1/3 is 2/6. So I now have 1 over 5/6. And when I'm dividing, I take the reciprocal. So this is equal to 6/5 when I substitute 0 in for x. So let's remember that. This is equal to 6/5. So now I just need to find what the values are for the answer choices when I substitute 0 in for x. And this is why I love 0, right? Let's look at A. 2 times x is 0, x squared is 0, 5x is 0. So the value in A becomes 5 over 6. Let's look at B. X squared is 0, 5x is 0, 2x is 0. So this is 6/5. I like that. 2x becomes 0, so C is 5. D is 6. So I think that I found my answer in B, because they're both equal to 6/5. So you may say, yeah, that sort of works, but you violated the assumption. Is that really the right answer? So next I'm going to show you how you could do this entire problem algebraically and how it confirms that B is the right choice. Stay tuned. Okay, let's look at what a full-on algebraic solution would be. So that's a rather messy denominator. So let's multiply it by x plus 2 times x plus 3. And I have to do the same thing up top. X plus 2 times x plus 3. And that ensures that I'm multiplying overall by 1 and not changing my original value. So let's take x plus 2 times x plus 3 and multiply it by 1. So up top, I'm going to have x plus 2 times x plus 3. And below, I'll have x plus 2 times x plus 3 multiplied by 1 over x plus 2. So I'm going to have x plus 2 times x plus 3 over x plus 2. I know this is getting long. plus x plus 2 times x plus 3 times 1 over x plus 3. So I'm going to have x plus 2 times x plus 3 over x plus 3. Yep, this is sort of messy, which is why we did the other method first. So let's now look at what we have up top. Let's just rewrite it for now. So x plus 2 times x plus 3. And what do we have below? Well, x plus 2 and x plus 2 goes away, which is great. And so I have x plus 3 plus the x plus 3 and the x plus 3 goes away. So I'm left with x plus 2. This is looking good. All right, let's continue. So we're going to do this multiplication by foiling. You may be familiar with that. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. And what do we have in the bottom? We have 4 things added together, so let's combine the like terms. X and x is 2x, and 3 plus 2 is 5. We're getting there. All right, now at the top, let's combine our x terms. I have x squared, which is not going to change. I have 3x plus 2x, which gives me 5x. And I have 6. And on the bottom, nothing will change. And what do you know? This is the whole simplified expression. It's the same as this guy here. So this solution shows that B, in fact, is the right answer. I hope you enjoyed seeing this solution, which confirms that the going rogue method that we used earlier actually led us to the correct answer. If you have any questions or suggestions or requests, feel free to leave them in the comments below. Subscribe to this channel to see the latest videos, and I look forward to working with you next time.